Problem 3, find a particular solution of d squared y over dx squared minus 9 dy over dx plus 2y equals xcx. Now, they've been using primes for the derivatives before, but in the first two problems, the y prime meant dy by dt. So in this section, they're kind of reserving the prime notation for dy by dt. So this time we have dy by dx. So they are actually using the full notation. And the same process. First, we look at the associated homogeneous equation. So I've just changed it into prime. Once we recognize that it's dy over dx, we can still use the prime notation. So y double prime minus 9y prime plus 2y is equal to 0. And the auxiliary equation for that is r squared minus 9r plus 2 is equal to 0. Now, this one doesn't factor, so let's use the quadratic formula on it. So, r will equal 9 plus minus square root. Okay, 9 squared is 81 minus 4 times 1 times 2. So 8 over 2. So this is square root 73. So you will get 9 plus minus square root 73 by 2. So this is a case of the roots are real and distinct. Okay, this is 73. And in this case, this is case number 1. So it will be this form. So YH would be C1 e to the R1t plus C2 e to the R2t, where R1 would be this one with the plus sign, 9 plus square root 73 by 2, and R2 would be 9 minus square root 73 by 2. And this one is XCX. And so none of these, after we substitute, will be of the XCX form. Therefore, we can safely, these terms do not match. Now, if you were actually solving the equation, you would substitute the R1 as 9 plus square root 73 by 2, and R2 equals 9 minus square root 73 by 2. So, in fact, let me just show you that. So we have 9 plus this one be x and not a t. So 9 plus square root 73 by 2, and then the other one will be 9 minus square root 73 by 2. That's okay, undo. This will be an x. And 9 minus square root 73 by 2. And usually we write the x after the constant, but that's okay as well. So clearly this is not going to match the XCX. So we just go for the basic XCX form. Do not match the right side. The given equation. Therefore, we can write the form of the particular solution. So the particular solution in this case, now remember when you have xex, let's go back to that little table that I showed you. So this one is of this form, a polynomial of degree n times e to the rt. So in this case, it would be general polynomial of degree n times e to the rt. Again, as we discussed, we don't need this t power k because nothing is matching the solution of the homogeneous equation. So the polynomial, we have here xex. So the polynomial is of degree 1. So now we go back. So this x is a polynomial of degree 1. So now what we do is we write the most general polynomial of degree 1. So the most general polynomial of degree 1 is ax plus b, or mx plus b. Ax plus b, that's the most general polynomial of degree 1, and times e to the x, because e to the x was already there. So if this had just been e to the x, then we would just write aex, a constant times ex. And let's say this had been an polynomial of degree 2. Let's say if this had been an x square, then here we will write ax squared plus bx plus c, because that's the most general polynomial of degree 2, and so on. So now once we've spotted that this is what yp is going to be, so now since in this equation we will need a derivative and two derivatives, so let's calculate them over here. Yp prime so, or maybe we can just do what we did in the previous problem. Just we'll calculate the derivatives along the way. We'll just substitute it here. So like that. So we can say substituting in the given equation. Now just copy it. Given equation was this one, the original one. Okay, so y will be replaced with this thing, ax plus b times e to the x. Okay, so now let's calculate the derivative of this. So it was 9 dy by dx. So let's remove the dy by dx. Let's keep the 9, and dy by dx is the derivative here. So 2 is just a multiplied constant, so I can keep that. And now basically take the derivative of, no, 2 was not a part of the yp, 2 was just a part of the y. So see, this 2 was coming from here. So the y was just ax plus b, so not this 2. Okay, so 9 times dy by dx. So just take the derivative of this one. So if you use the product rule on this factor ax plus b and the other factor e to the x, so the derivative of ax plus b is just a, and then you keep the other one, you keep the e to the x. The derivative of first function was a, and I kept the second function. And then, so negative 9 was a constant. So that out. Okay. So a is the derivative of the first function, the ax plus b, and I kept the e to the x, and then plus, now I keep the ax plus b, and I take the derivative of e to the x, which is e to the x. Okay, so you see, this was negative 9 dy over dx, so negative 9 is outside, and the dy over dx is this one. That's the derivative of this whole expression. And now it's a second derivative. So second derivative. So this bracket thing was the first derivative. So take the second derivative of f. Derivative of aex is just aex. aex. And then this ax plus b times e to the x. So remember, the derivative of ax plus b times e to the x is again found by product rule, and actually it was this whole thing. If you remember, this was the derivative of ax plus b e to the x. So I'm just copying this and adding it here. Yeah, so the derivative of aex was just aex, and the derivative of ax plus b e to the x was ax plus b e to the x. You can do it again, but since that's exactly the derivative which we did in the previous step, I'm just using that result. Okay, so the next step is to equate the coefficients of like terms, or compare the coefficients of like terms. So like, let me show you the previous problem. In the previous problem, after doing this step, we arrived here. So the two terms that were going on were cos 3t and sine 3t, and we compared the coefficients of those two on both sides and got two equations, and that helped us get the two constants. So in this case, after you simplify, so let's see what we get after simplification. So you have aex, you have another aex, so that's 2 aex. So let's see what comes with e to the x. So I'm just copying this. So with the e, when I add the aex and aex, I get 2 aex. So let's see if I have another. I have a minus 9 aex, so 2 minus 9 is negative 7. And that's it. So negative 7 aex. This one I've already added in. And negative 9 aex, I've taken care of that. Okay. And then what do I have after that? After that, I have this one is ax ex when I distribute. This is minus 9 ax ex. So ax ex minus 9 ax ex is negative 8 ax ex. And then another 2 ax ex. So negative 8 plus 2 is negative 6. So I have negative 6 ax e to the x. So I've taken care of all the ax ex's. So it means this one is gone. This was ax ex. This is gone. And this is gone. That's ax ex. Okay, so now what am I left with? Bex minus 9bex plus 2bex. So that's b minus 9b is negative 8b, and plus 2 is negative 6b. So negative 6bex. negative 6b ex. Okay. Negative 6b e to the x. So this is what I have after I simplify this left-hand side. And so now the two main terms that are going on are e to the x. Remember, it's the variable terms that decide what's going on. A is just a constant and b is just a constant. So to see how many different terms are going on, we look at the variable terms. So we have an e to the x going on, and we have an x e to the x going on. So we can first compare coefficients of e to the x. So you always start with the simplest one that makes your work easier. So we will say comparing coefficients of e to the x on both sides. Both sides of above equation. We can even name it both sides of 1. So when you compare the coefficients of e to the x, the coefficient here is negative 7a. Negative 7a. And here we have minus 6b. Minus 6b. And that's equal to 0. We don't have just an e to the x term because this is an xex term, not just an ex term. Okay, and then we will do the xex coefficients. Actually, I said that the ex was simpler because I was looking that it has 0 on the right-hand side, but actually it turns out that the xex is simpler. But doesn't matter. Okay, paste. So comparing the coefficients of xex, because for xex we have only one term on the left side. So both sides of 1, what do we get? So the xex term on the left side is negative 6a. I mean, the coefficient is negative 6a. That's the only xex term on the left side. And the right-hand side, the coefficient of xex is 1. So this was a simpler equation because that directly gives us a equals negative 1 by 6. A equals negative 1 by 6. And now we substitute it in here. So negative 7a. So this would imply negative 7 times negative 1 by 6. Okay, so let's see, what is this? This is 7 by 6. This simplifies to 7 by 6. Minus 6b is equal to 0, so 7 by 6 equals to 6b. Seven by 6 equals 6b. So b equals 7 by 36. Now we have both the constants. So you can substitute it in here. In the yp equation. X plus b. So ax plus b. So a was negative 1 by 6. So negative 1 by 6x, and b is 7 by 36. Okay, so negative x by 6 plus 7 by 36 times e to the x. Negative x by 6 plus 7 by 36 e to the x. Okay.